This is Unit 3, Lesson 4, Part 2. In the last video, we reviewed how inverses and their functions are related to each other, and we went through the process of where the definition for the derivative of an inverse function came from. So now in this video, we're going to practice finding derivatives of inverse functions. So to start with, let's go through the steps that you take. So first, you want to make sure that you're dealing with two functions that are inverses of each other, so that f of g of x equals x and g of f of x equals x, and that the points are switched. So if you have f of a and that equals b, then g of b equals a. So here's how we do this. If we want to find a specific point, g prime of b, for a point AB on f of x. So the first thing we do is we find f prime of x, and if you're only given b, which happens often, you set b equal to f of x because you need a. So then you need to find f prime of a, so your derivative is going to be 1 over f prime of a. Because remember that inverses have reciprocal slopes at corresponding points. Okay, so let's go through and fill in this table as our first example for what we're doing. Okay, so we are to find g prime of -1, where g is the inverse of f. So here's how we go through and do this. So we're just going to go ahead and fill in the rest of the table. For the first blank, g of x, so we're talking about x is 2, f of x is 5. So we're going to switch that, and so g of x is going to be 2, because this would be the point 5 comma 2. So g prime of x is going to be 1 over f prime of x. It's hard to see, I apologize. And that is going to be 1 over 0. So in this case, this is undefined. There is no derivative at 5, at the point 5 comma 0. So we'll do the same thing for the next one. So g of x for the next point is going to be 3, because we're dealing with the point now -1, 3. And then we're going to find the derivative, which will be 1 over the derivative of f prime of x, which would be -4. And then for the last point, the value is going to be -1. And our derivative will be 1/6. Because again, what we have here is that, remember, g prime of -1 is going to equal 1 over f prime of 3. And here, g prime of 4 is going to be 1 over f prime of -1. Okay? All right, so next example. Let g be the inverse of f. Calculate g prime of -9 for f of x equal to 4x to the third plus 5x. So we can go through the steps. You can do it the first two steps in either order. Sometimes you want to find what your x is first. Sometimes you want to find the derivative. It doesn't matter. So I'm going to go ahead and find the derivative first. So f prime of x is going to equal 12x squared plus 5. And then I also want to find, I need the y that goes with -9. So I'm going to set 4x to the third plus 5x equal to that -9, because remember, the a and the b are switched. So I'm going to solve this then for x to find the x that goes with that y value of 9 for f. And I'm going to have to do, this can't be factored, so I went ahead and I used our factor theorem from last year to find a point, and -1 works. So I can factor out a -1, a factor of x plus 1. So this factors into x plus 1 times 4x squared minus 4x plus 9. So from there, I could use the quadratic formula on this, but this is the point I want right here. Okay, so from that, then I can find f of -1 is 9. So then f prime of -1 is going to be 12 times -1 squared plus 5. So I get 17. So that means that g prime of -9 is going to be 1 over f prime of -1. So g prime of -9 is going to equal 1 over 17. Okay, so let's do another one of those. There are questions when you need to use a calculator to find approximations accurate to 3 decimal places. Here's an example of such a task. Example 5. If f of x equals 4x to the 7th minus x squared plus x minus 5, find f inverse prime of 3 accurate to 3 decimal places. So first thing we're going to have to do is solve f of x equal to 3. This will give us our a. Then we're going to differentiate. Then we're going to find f prime of a. And then we're going to take the reciprocal to find the derivative. So we're going to need our calculator for this. So let's just go through the steps. So step 1 says to let f of x equal 3. So we're going to do 4x to the 7th minus x squared plus x minus 5 equals 3. So solving this, letting this equal 0. Okay, so minus 8 equals 0. Then I'm going to go ahead and put that in my calculator. So just going to go ahead and put that in the calculator, and then you just find the x-intercepts. I'm not going to do that here. I'm sure you guys all can do that. So I'm going to enter the function. I'll just do that much. And then when I hit graph, I see that I just have the one intercept that I'm looking at there. So if you have an Inspire, you can just hit graph trace and it'll stop on that x-intercept. But if you have an 84, just to review, we want to find a 0. So I hit second trace and then I chose 0. And I just have to be to the left and the right of that 0. So I have a negative y value here. I hit enter. I move the cursor over. So now I have a positive y value. So the calculator is going to look in between those two. And it's going to give me the 0. Now you want to make sure you keep all those decimal places for now. And go from there. Okay. So I'm just going to write down x is approximately equal to 1.0, whoops, 10. Okay, and then the next thing we're going to do is we're going to find the derivative of f prime of x, and that's going to be 28x to the 6 minus 2x plus 1. And then the next thing we do is we are going to substitute this value in there. And I'm just going to, I just did it in my calculator. And so this is approximately equal to 50.1468. And then finally, to find our inverse that we want, so we want f inverse prime of 3. That's going to equal 1 over f prime of 1.106396. So this is going to equal 1 over my 50.1468. And I want the decimal equivalent to 3 decimal points, 0.0119. Oops, too far over to the edge. There we go. Okay, now That's how you find the derivative of an inverse. So derivatives of other bases. The reason why these are presented here is because they're derived from using inverse functions. Now, there's no other way around this. You guys are just going to have to memorize these. And they can be a little confusing because they look a lot alike. You have to recognize which one it is. So I'm looking into setting up some ways to help us remember these. So here they are. Let A be a positive real number, and A is not equal to 1, and let U be a differentiable function of x. So when we're taking the derivative of a base to the power x, the derivative is ln of A times A to the x. Number 2, when we're taking the derivative of A to the U, when U is a function of x, so it looks very similar to letter A. We have our ln of A. Here's the original derivative, so you take the derivative of that, which would be this derivative, and so we're using a chain rule here, and then we have to take the derivative of that function. So it's really number 1 with the chain rule. We've added the chain rule here is what we've done. And then for number 3, if we're taking the derivative of a base A, the log of base A of x, we get 1 over ln of A x. And then again, the next one is just the same thing, but now instead of just having an x, we have a function u. So not only do we have the derivative of the log, but then we include the chain rule again here to get the derivative of u. So let's do a few of these, and then we'll finish up in our last video. Okay, so let's do some examples here, and then that will be the end, just to practice these new derivatives. Okay, so the first one is y equals 3 to the x, which is our very first rule. So y prime is going to equal ln of 3, the base, times 3 to the x. And normally we write the 3 to the x in the front so that it's clear that it's not part of the ln. Or you can put the ln 3 in parentheses. Okay, letter B is our rule 2, because now we have a base raised to a function, not just x. So y prime is going to be the same thing. We're going to use our chain rule, so we're going to have ln of 4 times 4 to the 3x, and then we have to take the derivative of 3x, which is 3. So our final answer cleaned up is going to be 3 ln of 4 times 4 to the 3x, and if you want to be real fancy, you can write this as ln of 4 to the third times 4 to the 3x. So you really have ln of 64, and then you have times 4 to the 3x, which would be ln of 64 times 64 to the x. But you don't have to. You're fine right here, but just to show you in case it's a multiple choice question and you're wondering how your answer got all screwed up, that would be how. Okay, so next we're going to do the derivative of 5 to the x squared. So y prime is going to be, we're going to take the derivative of 5 to the x squared, which is going to be ln of 5 times 5 to the x squared. Then we're going to use the chain rule to take the derivative of x squared, which is 2x. So y prime is going to equal 2x ln, or you can put the times 5 to the x squared, ln of 5. And then finally, the last one of this type, y prime is going to be ln of 5. And then we're going to have our 5 to the 3 minus x squared. And then we have to take the derivative of 3 minus x squared, which is negative 2x. So our final answer will be negative 2x times 5 to the 3 minus x squared times ln of 5. So we'll stop there and we'll finish up in the next video.